Hello, welcome back. So this is 6B, the normal distribution examples continued. Okay, let's go back to slide 6 for a moment. So slide 6 asks, what does the distribution look like for z equal to 0.03? And I realized what I did wrong. Nothing like pasta with meat sauce to get the brain really going. Okay, so when the question is asking about z equal to 0.03, right? The important thing to remember is the units. This is 0.03 standard deviations or standard deviation units, right? This is not 0.03% or 3%, okay? The units. So I did this completely wrong. We can't just add standard deviations to percentages. We need to go to our table and look at what the conversion is. So let's draw a picture. Oops. Here's 0 standard deviations, plus 1 standard deviation, plus 2 standard deviations, minus 1, minus 2. Okay, so, and it's asking us about z equal to 0.03 standard deviations. Okay, so if I go back to the table on slide 5, this is slide 6 that I'm talking about. If I go back to the table on slide 5, then the person with this height is 0.03 standard deviations above the mean. What percentile is this? Okay, so now I need to go back to slide 5 to the table. I see where z equals 0.03. Oh, let me draw my representation of this person's height at 0.03 standard deviations. Okay, 0.03 standard deviations. I see the larger proportion and the smaller proportion. Usually when we're talking about what percentile it is, we want to know the proportion that the person is above. So what percentage of people is the person with a z-score of 0.03 standard deviations? What percentage of people are they taller than? Okay, so how many people are below them, okay, for percentile rank. Okay, so for the people below them, right, that's going to be the larger proportion, just by a small amount, but the larger proportion, and I'm looking at that row, 0.03, the larger proportion equals 0.512. Okay, and that's the proportion, or 51.2% is what the table tells us that we can is the conversion between 0.03 standard deviations to the percentage. So you see I was way off, okay, because I was mixing up standard deviations and percentages or proportions. Okay, and then, so we know that the percentile is going to be 51.2, and it looks like it's 48.8% of people are taller than this person whose height is 0.03 standard deviation units. Okay, so if you go back to slide 6, it said, what if the z-score had been minus 0.03, right? So then we're over here, and it's these people, right? And basically this just reverses. The smaller proportion, the 48.8% is from here on, and the 51.2% is from there on. Does that make sense? Okay. All right. So now let's go back to where we left off, which was talking about these SAT scores. Now, of course, you know, the SAT nowadays it has like 3 parts, right, instead of 2. So this example using the SAT scores from 2000, you get the picture, but if we were to use current SAT scores, the actual numbers would be different. And if you look at slide 13, you'll see a picture that's very similar to the one that I drew on my paper. So I'm on slide 13. And it says 83% of students meet NCAA requirements. Okay. And this is negative 0.95 SD. Okay. So maybe we should just make it a practice. Every time we're talking about Z-scores, we'll put the SD after to show that we're talking about something that's measured in standard deviation units. That could make things clearer. Okay. Now, I don't know that much about sports. I know there are some of you who know a lot more about sports. And I just kind of blithely said, oh, it seems like these NCAA requirements are fair, but they might not be. And I bet some of you know really good reasons that they might not be. So I'd like to invite you to comment on the NCAA regulations and requirements for participation in a question and answer section of our discussion area, okay? Because statistics aren't neutral. They give you information, right? But it's never neutral. There are consequences. There are consequences for the statistics that we use. And so I'm sure some of you can talk more about potential consequences of this so seemingly fair SAT cutoff score. Okay? All right. Let's move on to slide 18. Okay, so this SAT verbal scores. Let's just look at a verbal SAT score, which is normally distributed with a mean of 505, and it's out of 800, right? And a sigma of 110. So a standard deviation of 110, a population standard deviation of 110, and a population mean of 505. What verbal SAT score will place a student in the top 10% of the population? So let's draw a picture. So, oops, wait, no, did that wrong. We're on slide 14. And in Z-land, mean of 0. Okay. Plus 1 standard deviation, plus 2 standard deviation, minus 1 standard deviation, minus 2 standard deviation. But the question is asking us about percentages. Now, let's see. I know that 34%, and then another like 14%, right? So to have 10, let me look back. to have that 10% in the top 10% is going to be, since like 68% of the data is between here and here, right? So this 50 plus 34 is 80-something percent. Is the one standard deviation is going to be around 80, the 84th percentile, right? And we're asking in the top 10%, which means the 90th percentile, right? So it's going to be more than one standard deviation, somewhere between one standard deviation and two standard deviations, is some z-score whereby above which is 10% of the students, okay? But we don't know the z-score, all right? We know the percent. And now I am going to be sure to do something with the table instead of mixing up my standard deviation units and my percentages. Okay, back to slide 14. Okay, so this is a smaller proportion, right? 90% would be the larger proportion. The smaller portion of 10% looks like, I'm looking at the column that says smaller proportion. I see 0.1003, a proportion of 0.1003 as the area under the curve. So that is close enough. So that, and if I slide over to the left, I see that corresponds to a z-score of 1.28 standard deviations. Okay, so now I found the z-score that will give us the top 10%. All right, and so we're able to go either way. We're able to go from the percent to the z-score or the z-score to the percent. And let's go on to, on slide 16, there is a, it just goes through exactly what I did on this page. Okay, 10%, yep. And there's now that's a z-score. Now, if we want to convert from the z-score land where we're talking about standard deviations to the SAT score, right, then we need to use that formula that you see there on slide 16. Okay, so if we want to go from the standard deviation units back to the actual SAT points, we have to use the formula because really nobody really thinks in standard deviation units. So, you know, if I'm talking to a junior and I say, hey, look, if you want to go to that college, you got to score in the top 10%. That means on your verbal SAT, you need to score 1.28 standard deviations. They're going to look at me like I'm crazy, right? Because what are you talking about? Okay, so let's convert it. And as you see on that slide, X equals Z times the standard deviation plus mu, or Z times sigma plus U. 1.28 is what we got. That's our z-score times 110, which is our standard deviation for the SAT verbal, plus 105, which is the mean, the population mean for the SAT verbal, equals 646 points. So a student would need to score 646 points on the verbal section if they wanted to be in the top 10% of SAT test takers. And remember, this was the year 2000, so this might have shifted a bit since then. But, you know, I could say to a junior, you know, hey, you're going to need to score, you know, like over 600, almost 650 on your verbal in order to reach this target that you're going to, or in order to get into the college that you're looking at, that most of the people who go there score within the top 10% on their SAT verbal. And then they'll be able to understand that. Yeah, okay, I need a 650. Okay, I'm going to study. All right. And slide 17. What if we wanted to know what scores represented the middle 90% and what the cutoffs were for the outside 10%? And so that would be 5% on each side, right? So the middle 90%, what scores represented the middle 90%? And 5% on either end. If we look at the table, what Z will give us 5% on each side? I'm looking for a smaller proportion equal to 0.05. And I go all the way down to the bottom, and there is a smaller proportion, 0.0500. I slide all the way over. 1.645 standard deviations is the Z. So positive and negative 1.645. Okay, and so then if we use the negative value, we'll get the lower. If we use the negative Z, we'll get the lower value. If we use the positive Z, we'll get the upper value. So if we, in the formula, if we put minus 1.65 times the standard deviation, 110, plus the mean, then we'll get the lower value. And positive 1.645 times the standard deviation plus the mean will give us the upper value. Okay, so if you need to know what's in this middle range, okay, this middle portion. All right, slide 20. If I draw an SAT, we're talking about probable limits. Okay, this allows us to make estimates about the range in which a score will fall. And you're going to see this kind of concept come up again. So probable limits. If I draw an SAT taker's score at random, 90% of the time her score will fall between what and what? Okay, and so if we did the actual math, we would see 90% of the time what it would fall between. And this allows us to make estimates about the range in which a score will fall. Okay, and this idea of kind of what would we get 90% of the time, what would we get 95% of the time, that kind of idea is going to be important. So, slide 21. In summary, most scores, 68%, fall within one standard deviation of the mean. Z-scores tell us how many standard deviations a particular score is away from the mean in standard deviation units. We can then use a table to determine the score's percentile or probability of occurring. Okay, and likewise, we can, if we know the percentile or probability of something occurring, we can then use Z-scores to then work our way backwards to find out what a particular value might be in the real world of whether it's SAT points or height or whatever it is that we're measuring. So I hope this has been interesting. The Z statistic is many of you may remember, you've done averages, you do averages all the time. You may even remember median and mode from either your own studies or helping someone else with their homework. But Z-scores are usually the first statistic that folks aren't as familiar with. So you're going to get a chance to practice that, and I'll talk with you soon, and happy statisticking.